Okay, so in this video, I'm going to work on how reference angles can be used to get the value of the trig function of an angle. And the whole idea is to not use a calculator, to use the idea of reference angles together with what you know about those special right triangles. Okay, so things you need to remember. You need to remember 30, 60, 90 triangle. And a 45, 45, 90 triangle. It doesn't look so good, but pretend it's drawn accurately. Okay, and then you just need to keep up with what the sine, cosine, and tangent is for those. Okay, and so let me make just a little chart here. I like to keep the 30 and the 60 together, and then we'll do 45 on the last spot. Move that up just a bit. Okay. All right, so you can look at the triangles and think about sine of 30, that would be opposite over hypotenuse. Sine of 60 would be square root of 3 over 2. Cosine of 30 would be square root of 3 over 2. And cosine of 60 would be 1/2. All right, and then if I did tan of 30, that would go here. Tangent of 30 would be 1 over square root of 3, but you'd have rationalized it. And then the tan of 60 would be square root of 3 over 1, which is just square root of 3. And then for 45, 90, the sine is 1 over the square root of 2. And when you rationalize it, you get square root of 2 over 2. Cosine turns out to be the same thing. And because sine and cosine are the same, tangent turns out to be equal to 1. Or you can think 1 over 1, but it equals 1. Okay? So that's something you need to know. And this chart just kind of reminds us of that. Then that big observation that reference angles and the original angle will have the same trig value. You just might need to put a plus or a minus in front of it. Okay? So what you want to do is you want to think about where the angle is located. So 300 should be about right there. 30 degrees past 270. So that means the theta prime right here is equal to 60, isn't it? So if this is 300, you're 60 degrees away from a full rotation. Okay, so that means to do the sine of 300, the sine of 300 is going to equal the sine of 60, but we have to think right here about whether it's positive or negative. So the best thing to remember is that sine is associated with the y coordinate. So like if you imagined a point on the terminal side that was 1 unit away from the origin, the y value of that point would be the sine. So just think about y being associated with sine and x being associated with cosine. So can you see if you were to plot that point right there, how you would have had to go down to get there, which means the y coordinate would be negative. So you are going to need this negative right here. That's the important thing. And then you already know the sine of 60 is square root of 3 over 2. So there's your answer. All right, and even if your calculator can handle the radicals and give you the exact value in radical form, I'm expecting to see a diagram and a thought process that shows how you used reference angles to get the exact value. Okay. All right, so let's do some more. So on the tangent of 5 pi over 4, you would figure out where that's located. So if the denominator is 4, that means you're cutting that top part of the circle into 4 pieces. So you have to go all the way around to 5 pi over 4. That would be right here. And remember, your reference angle is going to be the angle between the terminal side, so here's the terminal side, and the x-axis. So this is the reference angle. And so how far past pi are you? Well, that's 4 pi over 4, so this would be pi over 4, wouldn't it? So that means that the tangent of 5 pi over 4 should equal the tangent of your reference angle, but we just got to think about whether tangent is positive or negative in that quadrant. So we think about being in this quadrant and how both the cosine and the sine, if you went to a point on this terminal side, the cosine would have been negative, the x value would have been negative, and so would the y value. So cosine and sine are both negative, which means this is going to turn out to be positive. So it turns out to be exactly the same as the tangent of pi over 4. And so pi over 4, that's that 45-degree angle, so it's going to wind up having a value of 1, positive 1. Okay? And that would be your answer on B. Okay? I'm going to do one more, and then I'm going to do them all, but I'm going to do one more, and then I want you to pause the video, and I want you to do the other 3, and then you can just play the video and check and see if you've got it. Okay? All right, so here's the idea then. I'm going to think about where the angle negative pi over 6 would be. Okay, so that would be like cutting this bottom half of the circle into 6 pieces. And so it would just be kind of like right there. You would have just gone that far. That would be negative pi over 6. Okay. So the reference angle for that would be the positive acute angle representing this right here. So theta prime would equal, put it here, theta prime would equal positive pi over 6. Okay. All right, now secant is really just the reciprocal of cosine. So the SIGN of secant will be the same as the SIGN of the cosine. So I'm just thinking about how I'm over here in the 4th quadrant and how the cosine, since you're to the right here, your x coordinate would be positive. So that means the secant of negative pi over 6 is going to equal the same thing as the secant of positive pi over 6. All right, now, personally, when I do these, what I do first, if I'm dealing with like secant, is I think, okay, well, the cosine of pi over 6, and, until you're really good at this, pi over 6 is really 30, isn't it? 180 divided by 6. Pi over 6 is really 30. And so I'm going over here and I'm thinking, okay, cosine of 30, well, that's square root of 3 over 2. Okay. And so the secant of pi over 6, so now I'm going to go up here. Secant of pi over 6 should be the reciprocal of that. And cosine and secant, they're both going to be positive in that quadrant 4. So I don't have to worry about the sign issue. Then all I got to do is rationalize it. Okay. Let me just move that a little bit out of the way. Okay, so that's going to wind up being 2 square root of 3 over 3. And that would be my answer. I had to fit it in a tight spot, but hopefully you could follow it. So let's go back through that again. So negative pi over 6 has a negative clockwise rotation, just a little bit, just 30 degrees. It's like you broke the bottom half of the circle into 6 pieces and just went one of them. The reference angle then is the angle formed by that terminal side in the x-axis. So the reference angle would be right here, and that would be pi over 6. All right, now this angle is in the 4th quadrant. So the x value, if you had a point that was on the terminal side, the x value would be positive. And so that meant when you're comparing the secant of negative pi over 6 to the secant of pi over 6, this is going to have a plus. So it'll just be equal to the secant of negative pi over 6. Now this was a little harder than the others because it involves secant. So when I'm doing that, I just think about doing the cosine. And cosine of 30 was square root of 3 over 2. And then secant should be the reciprocal of that. But that gave us a radical in the denominator, so I had to rationalize it. But there I have my final answer. All right, so if I were you, I'd pause the video, do these other 3, and then check and see if you were able to reason out the correct answer. And make sure you see how to draw the sketch and then think through the use of the reference angle. To get credit on this, I'm going to have to see that kind of reasoning. Okay, so now you're back just trying to check if you did these last three correctly. So let's go ahead and get these on here. So 17 pi over 6. So think about breaking this up into 6 pieces. All right, so 17 pi over 6 would be, all the way around once, would be 12 pi over 6. Okay, so 12, 13, 14, 15, 16, 17. So I'd be like right there. Okay. All right, so that would be 17 pi over 6. All right, it actually might help you if I showed the 6 pieces, or if you had that diagram, that has it cut already into 6. All right, so going around all the way around once is 12 pi over 6, and then that would be 13, 14, 15 pi over 6, 16, 17 pi over 6, and that means I'm only this far away from the x-axis, and that's where the reference angle is located. So that's your theta prime. So it's 1 pi over 6. It's just pi over 6 away from the x-axis. So that's your reference angle, right? So theta prime equals pi over 6. So here's what you do then. So the cosine, the cosine of 17 pi over 6 should equal the cosine of pi over 6, but I need to think about what I should do in front of it. Is it positive or negative? So cosine of pi over 6 is really in the first quadrant, so it's always positive. But you see over here in the second quadrant how I have to go to the left, which means the x-coordinate would be negative, and cosine's associated with the x-coordinate, so I am going to need a negative in front of that. And then I just think about pi over 6, that's really 30 degrees. So this is going to equal a negative square root of 3 over 2. Okay, so your answer should have been negative square root of 3 over 2 on that one. All right, so let's see what happens with this. This one, I think, is a typo, sorry. This one's really a typo because you can't do a denominator of 34. Doesn't turn out to be a special right triangle. Sorry about that. Just noticed it. So let's make this just 4. I'm sure it was meant to be a 4 or a 3, either one of those. Let's do a 3. Okay. So this is a typo. Change it to like a 3 here. Let's see what happens. All right. So if we make that a 3, then that means I'd have to go in the clockwise direction. This right here would have been 6 pi over 3. That would have been another 6 pi over 3. So that would have been 12 pi over 3. Okay, I can even go another one, can't I? Can I? Let's see. 6, 6, 6. Yep, that would be negative 18 pi over 3. And if I'm doing pi over 3, that means I'm cutting this into 3 spots. Okay, it's cutting this into 3. So here I am. And remember, I could go around 6 pi over 3 would be a full rotation, and then 12 pi over 3 and 18 pi over 3 is another, but I can't go around a whole nother time. So now I'm ready to count. So this would be negative 18 pi over 3. That would be negative 19. This would be negative 20. That would be negative 21. This would be negative 22. So if I made the denominator a 3, this would be negative 22 pi over 3 right here. Okay. All right, now what you want to do, let me change colors, is you want to know, well, what's this angle between the terminal side and the x-axis? So see how that's just 1 pi over 3? That's the reference angle. Okay. Then notice that you're in the second quadrant here. Okay, you're in the second quadrant, and the y-coordinate of a point on the terminal side would wind up being positive because you had to go up. So sine is positive there. So this would equal just the sine of pi over 3. Okay, and so then you can go back to your 30, 60, 90 triangle. Pi over 3 now is 60, and you're doing sine. So it turns out equaling square root of 3 over 2. So again, sorry about that. You may have not known what to do with that one, because if it had a denominator of 34, you wouldn't be able to use reference angles to get the exact value, because it wouldn't turn out to be a special right triangle. All right, let's see how cosecant went. Okay, so let's check on where is 9 pi over 4. Okay, so that means I'm splitting things into 4 pieces. Sorry, it's hard to write. I have to keep my screen vertical. Okay, so 9 pi over 4. So that means I'm going to go counterclockwise. This would be 4, 5, 6, 7, 8 pi over 4. So that's 9 pi over 4. So this one's not very interesting, because right here would be this angle, just right here, would be pi over 4. That's your reference angle. Okay, and it's actually coterminal with that one. It's actually going to be exactly equal to cosecant of pi over 4. Okay, so the only thing that's going to happen on this one is the fact it's not sine, cosine, or tangent. So what you should be thinking is, well, that's related to the sine of pi over 4. So do you see how these both would have the same exact cosecant? 9 pi over 4 is just an extra rotation around. So that would just stay positive out in front. Okay, now sine pi over 4 is square root of 2 over 2. Okay, and so cosecant pi over 4 should be the reciprocal of that. And see, if you've memorized it as square root of 2 over 2, then when you flip it, you're going to say 2 over the square root of 2, but then you'll have to rationalize it. So that'll be 2 square root of 2 over 2, because you would have multiplied the top and bottom by square root of 2, and then the 2's would cancel. So your final answer on that one should have just been square root of 2. All right, and then if you use the chart, you might have flipped right there and already had the square root of 2 over 1. Okay, so using reference angles to find the exact value. So you're not just going to put your calculator in degree mode or radian mode and just type these in. The intent is for you to draw the angle, the original angle, find the reference angle, and then understand that the relationship between the original angle and the reference angle is that they're going to have the same numerical part. The signs of those two should be the same numerical part, and then all you got to do is adjust by putting a negative in front of it sometimes. Okay, so you have to think about what the SIGN of the trig value would be and make sure you have that right. Okay, so really concentrate on that when you have that in homework. Okay, one other thing from this notes page I wanted to do is just develop the unit circle. So I'm going to do that in a separate video.